Hey guys, it's Mrs. Flood. This is your video for our first day back from spring break. I hope you guys all had a great time. Maybe you got some sun, maybe you did some traveling, maybe you stayed home and relaxed. Today, we're going to be talking about factoring trinomials. And before we get started, I want to make sure we understand the terms that you see on the screen, because you're going to hear me using them throughout the video. So remember, a trinomial is a kind of a polynomial. A trinomial specifically has three terms. And today you're going to see me using ones that look like this, where the coefficient on my x squared is a 1, the coefficient on my x is a b, and the final is a c. Mostly, though, you'll see me write it like this, where I'm not including the implied coefficient on the x squared. Our other word, factoring. Factors are things that other things can be divided by. And examples of that, something maybe looks more like math than things and something, could be this. The factors of 12 are all of these numbers and all of them when they're negative. So factors can be positive or they can be negative. You'll see both throughout the video today. So let's get started. If you recall, when we talked about exponents, I showed you a slide that maybe looked a little bit like this, right? It had 4 different corners, and the corners were classified by when things were positive and negative. Now, in exponents, at that point, we were talking about powers as bases, and so the things that were positive and negative were the exponents inside the base and the exponent being applied to the base. Well, here we're not talking about exponents, but we are still looking at the signs. And specifically, we're looking at the signs on your C term and on your B term. So if you look at each of these 4 cases, you'll see that the C and the B signs are changing, just like the words are changing. And we're going to talk about each of those 4 cases, and we're going to be going clockwise through the slide. So we're going to start in this corner over here, talking about cases when both of these signs are positive. So you should remember seeing this diagram in the corner. This was from the factoring puzzles that we did on Wednesday before break. And I know it might feel a little bit rusty for some of you, but I think it'll come back to you as we go through. Now, if you didn't do the factoring puzzles, right, if you never got a chance to do that before break, you might want to stop the video now and go try those. This would be a lot easier if you have practiced these a few times. So if you haven't done it, I suggest you go do it. If you have done it, stick with me and we'll keep going. So the factoring puzzle looked like this, and this is the trinomial that you would create from this factoring puzzle. And if you'll recall, in the factoring puzzle, we were looking for 2 numbers, one would go here and one would go here, that if you multiplied them together would make this side, positive 15, and if you added them together, would make this side, positive 8. So you see a positive 15 here and a positive 8 here. And that's how we constructed this trinomial from this factoring puzzle, that is. So in this case, we have a positive number, a positive 15. Well, in order to get a positive 15, we either have to multiply 2 positive numbers or we have to multiply 2 negative numbers. So we already know something about what our factors are going to be. But then we know we're going to need to add those factors to get to our 8. And that 8 is also positive. And the only way to add to a positive number is to start with 2 positive numbers, at least from these 2 choices. We can't add 2 negative numbers and end up with a positive number. So we can already then write this. We know there's going to be an x in each set of parentheses, and now we know that we have a positive sign on each parenthesis. So now we can look at the factors of 15, and we only have to consider the positive factors of 15. So 1 times 5 gets us 15. 3 times 5 gets us 15. So now we know ways that we can get this. The question is, what happens if we add our factors? Can we get to positive 8? So let's check. 1 plus 15 gets us 16, not what we want. 3 plus 5, that gets us 8. And some of you probably realized that before I got to this point, but we're going to go through sort of methodically to make sure that we understand all the steps. And now we could use the information we found to write our solution. X plus 3 times x plus 5. Those two are the factors of this trinomial. And we can prove that by multiplying them. So we do first, outside, inside, and last. And we would get these 4 terms. And when we simplify, yep, there's the same trinomial we started with. And these were the 2 numbers that would have gone in the factoring puzzle when you did it on Wednesday. Here's another one we can try. So now we have a 10, a positive 10, and a positive 7. So 10 is positive. Therefore, we know that either we have to have 2 positive factors or 2 negative factors. So we can list our options. And they would look like this. A positive 10, 1 and a positive 10, a negative 1 and a negative 10, and then positives and negatives for 2 and 5. But then we look at our positive 7 and we say, wait, this is positive. That means both my numbers have to be positive because I can't add 2 negative numbers to get to a positive. So now we add the remaining possible pairs of numbers, and we add positive 1 and positive 10, but that gets us 11, not what we want. We add 2 and 5, and there's the 7 we were looking for. Now we can write our answer. X plus 2 times x plus 5 produces this trinomial. These are the factors of this trinomial. Here's an example I want you guys to do on your own. So you should pause the video now and you should go try this with pencil and paper. And when you're done with that, you should restart the video and I will explain the answer and you can see if you got it right or wrong and maybe figure out if you didn't get it right, what you should have done instead. So pause your video now and I'll be here when you get back. All right. Hopefully that went well for you. Let's see how this one gets solved, and you can see the answer in just a moment. So we should have started off by looking at our 20 and realizing that 20 is positive. There's that positive sign in front of it. So we know that our factors have to either both be positive or both be negative. So we can list the possibilities. And we list all of these that you see here. 20 has quite a few factors, so there's a lot of possibilities. And they're in pairs, both positive or both negative. But then we go and look at the positive 12 here. And that is positive, so we know that the only options that we really need to examine are our positive options. So we add those options, and we do 1 and 20, and that doesn't get us what we want. And then we do 2 and 10, and that does get us what we want. And we can just stop there. There's no reason to check the final option. You have found your solution right here. So we know it's 2 and 10, and we can write it. X plus 2 times x plus 10 will produce this trinomial. We're going to move on to our next quadrant, this one up here. We're going to talk about a case where we have a negative sign and a positive sign. That's the next one we're going to look at. So here's another factoring puzzle that you should already have done last week. And this is the trinomial that it would produce. A positive 8 from the side where we multiply and a negative 6 from the side where we add. Because the 8 is positive, we know that we have to either multiply 2 positive numbers or 2 negative numbers. That's the same as the last case we looked at. But now our 6 is negative. We can't add positive numbers to get to a negative 6. We can only add negative numbers. So we know that our end result is going to have to start by looking like this. An x minus times an x minus. So what things, negative, can we multiply together to positive 8? Well, negative 1 and negative 8. Or negative 2 and negative 4. So those are our negative pair options. And then we add them. First we get a negative 9. Oh, and look, there is our negative 6. That's what we wanted. And we can write our answer. So x minus 4 times x minus 2, that is the factor pair for this trinomial. And it doesn't really matter whether you put the 2 over here and the 4 over here. If you wrote these in the opposite order, it would be perfectly fine. They're still both negative. It doesn't really matter. You'll get the same answer either way. And let's solve that just to prove that we're right. So we do first, outside, inside, last. We get these 4 terms. And when we simplify, there's the trinomial. And you see here are our answers filled in our factor puzzle. So let's try this one. We have a positive sign and a negative sign. We want to start by looking at this side and see it's positive, so the factors must be both positive or must both be negative. We can list our options, all of our negative options, all of our positive options. But now we look over here and we say, well, the negative 11, that's negative, so I have to have 2 negative numbers. So now I can add those possible pairs. I only have to do half of the ones that I originally identified, so let's look at those. A negative 1 plus a negative 24 gets me a negative 25. Negative 2 and negative 12 gets me negative 14. Ah, there's what I was looking for. Negative 3 and negative 8 get me that negative 11 that I wanted. So I can stop. I don't have to check the final negative pair, and I write my solution. X minus 3 times x minus 8. These are the factors of this trinomial. You should pause your video again. Here's another chance for you to test your skills on your own. So you should pause me, get out some paper and pencil, work through the problem, and when you're ready, you can restart the video, and I'll be here to explain how you solve this one. All right, hopefully that went well for you. I bet it did. So let's look at our solution. We start by looking at our positive 20. It's positive, so our factors have to either both be positive or both be negative. So we can list our pairs, and here are our options for 20. Negative pairs and positive pairs. And now, though, we look here and we say, oh, this is a negative 9. Both of my factors have to be negative numbers. I can't add 2 positive numbers and get a negative result. So it has to be a negative plus a negative. So now we add just the negative pairs, starting with negative 1 and negative 20. Nope, that doesn't work. Negative 2 and negative 10. Nope, that doesn't work. Ah, and there's one that does work. There's the negative 9 we are looking for. Negative 4 plus negative 5 gets us that negative 9. And we can write our solution. X minus 4 times x minus 5 produces this trinomial. These are the factors. So let's move on. We've done positive. We've done negative. Coming around clockwise, we're going to negative. So we're going to work in this quadrant now, where our B is negative and our C is negative. So here's a factor puzzle. We have a negative 6 and a negative 1. I chose to be very explicit about the negative 1 when I wrote it. You might often see this without the 1, just written as x squared minus x minus 6, but I've written the implied coefficient to make it easier to see. So we know if we have a negative product, you had to start with a positive times a negative. There's no other combination. Now you could say it could be a negative times a positive, but really it's the same either way. So knowing that, we list, but let's check one other thing first. Let me talk about one other thing first. In order, however, to get a negative number on this side, this negative 1 here, we have to have the negative factor have a greater absolute value than the positive factor. Right? And we'll look at that in just a minute. If that didn't make any sense, just keep watching and it'll make more sense in a minute. So we know then to start with, we're going to have an x plus and an x minus, because we have to have a positive and a negative to get to this result here. So what I said was that our negative number has to have a greater absolute value than our positive number. Right? So let's look at what that could be. For negative 6, 1 times negative 6, because you have to have a positive and a negative. And if you take the absolute value of negative 6, that is 6, which is greater than the absolute value of 1, which is 1. And then negative 3 times 2, the absolute value of negative 3 is 3, which is greater than the absolute value of 2, which is 2. And you get a negative 6. And you only have to test those two options, because if you put the negative sign on the other one, you couldn't get to a negative 1. So 1 plus negative 6 gets you a negative 5. And 2 plus negative 3 gets you a negative 1. And that's what we're looking for, that negative 1 right there. So we can write our answer, x plus 2 times x minus 3. And we can prove that by multiplying them together. First, outside, inside, last, produces these 4 terms. Simplifying gets us back to our original trinomial, and we can see our answers written into our factor puzzle here. Let's try this one next. We start off looking at the negative 35. Now we know that our factors have to be both a positive and a negative number. We have to have one of each. So we can list our possibilities. And now if you look, I have a positive and a negative. A negative and a positive and a negative. And the same thing here. One number in each pair has to be positive and one number in each pair has to be negative. But now I look at my negative 2. And so I know that because the result is negative when I add my factors, the negative factor has to have the greater absolute value. So negative 35 has a greater absolute value than 1. Negative 7 has a greater absolute value than 5. And look, when I add these two together, there's my negative 2 I've been waiting for. We write our result, x plus 5 times x minus 7. And that's our answer. All right, now it's time for you again. It's a chance for you to practice the negative option. So pause your video. You know I'll be here when you get back. Take some time, work through it carefully, pen and pencil and paper, and come back when you're ready to hear the answer. All right, let's see how this one went for you. Starting off, we look at our negative 21. It is negative, so we have to have a positive and a negative number in our pair. We can list our options. And here we have negative, positive, positive, negative, negative, positive, positive, negative. These are the possible factor pairs. And now we look at our negative 4. And it is a negative number, so we know that the negative factor in our pair has to have a greater absolute value. So we add those possible pairs, and the ones that we consider are 1 and negative 21. Negative 21 has a greater absolute value than 1, and we get negative 20. And 3 and negative 7, and there is our negative 4. So there is our answer. X plus 3 times x minus 7. Those are the factors of this trinomial. Our final quadrant, we've been working our way around clockwise, and so we end up in the positive-negative corner down here. And we're going to talk about the case where the B is positive and the C is negative. It's quite a bit like the one we just did, and we'll see how those are related in just a moment. So here's our factor puzzle. Because it's a positive and a positive here and a negative here. Because this is a negative number. This is a negative number, so we have to multiply a positive by a negative to get this negative number. And because this is a positive number, we know that our positive factor had to be bigger, have a greater absolute value than our negative factor. And we know that our form in the end is going to look like this, with an x plus and an x minus. So you could already write that if you wanted to at this point. And then, like we said, the negative number here is going to have a smaller absolute value than the positive number that's going to go here. So we list our possibilities. If you look, all of the negative numbers have smaller absolute values than their corresponding positive factor. All of these will get you to negative 36, but let's see what happens when you add them. 35, 16, 15, there's the 5 we want. So we write our answer, x plus 9 times x minus 4. And as I said before, if you wrote the negative 4 on this side and the positive 9 on this side, it would still be correct mathematically. When you multiply them, you will still get the same result. It's not a problem, the order in which you write the factors, as long as the sign stays with the number that it belongs to. So we can multiply this and prove that we're right. X squared, negative 4x, positive 9x, negative 36. First, outside, inside, last. Simplifying, and we get back to our original trinomial. Let's try this one. We start off looking at our negative 15, which is negative. So we have to have a positive factor and a negative factor. We list our possible pairs, and they are these. And in each pair we have a negative and a positive. Then we look at our positive 2 and we say, oh, this is positive. So now the positive factor has to have the greater absolute value. So we add the ones in which the positive factor has the greater absolute value. Negative 1 plus 15 gets us 14. 15 has a greater absolute value than negative 1. Negative 3 and 5, and there's the positive 2 that we've been waiting for. So we write our answer. X plus 5 times x minus 3. These two things are the factors of this trinomial. This is the last one you're going to have to do on your own. So put your video on pause now, and I'll be here to explain when you're done. Go work this one on your own. All right, let's work through this last one and see how you did. So we start by looking at our negative 27. We know our factors have to be a positive and a negative. We list the possibilities, and we have these 4. A negative and a positive and a negative, and then the same signs down here. Because the 6 is positive, right here, we know that our positive factor has to have a greater absolute value than our negative factor. So we look at the possibilities in which that's the case. 27, our positive factor has a greater absolute value than negative 1, our negative factor. So we check that one, but it doesn't give us 6. And then we check negative 3 and 9, and that does give us 6. So we can write our answer, x plus 9 times x minus 3. These are our factors for that trinomial. Okay, we have gone through all 4 of the cases. And at this point, you ought to be able to factor trinomials where there's a 1 in front of the x squared and have a b and a c. Now, do keep in mind, sometimes you get trinomials that don't factor neatly using these techniques. But you should expect for your homework tonight that they will work neatly. Right? If you can't find an answer, you probably need to try again. In the future, you might find some that don't factor neatly, and we have other methods to deal with those. But for now, assume that you will be able to come up with whole number, integer factors to solve these. All right. I will see you in class if you need some help just come back to the room and ask me.